Alright guys, this video is to help you guys out with chi-squared of homogeneity. I hope I'm saying that right. I'm not even sure. No, I didn't even spell that right. There should be an I right there. Sorry about that. It's hard to say, hard to spell, but easy to do. So here we go. So throughout this video, we're going to do a lot of stuff by hand, but also by calculator, so that way you get a little bit of practice of everything. So in the study of the television viewing habits of children, a developmental psychologist selects a random sample of 300 first graders, 100 boys and 200 girls. Each child is asked which of the following TV programs they like the best. So we're trying to figure out if maybe boys or girls, if there's some sort of association with the type of programming they like. Okay, so we're going to do a chi-squared of homogeneity and not goodness of fit. And the reason we're not going to do goodness of fit here is we've got two variables. We've got gender and we've got viewing preference. So we don't have a list. A list would be just maybe the television shows, like children that like it. But since we've got two variables, we have to use a table, which then makes us use homogeneity. All right. So we're trying to figure out if there's an association between gender and viewing preference. So before we actually get into the problem, let's practice doing one of these by hand. Let's figure out what is the expected value for the Lone Ranger and boys. So how many boys do you expect to watch the Lone Ranger? And the Lone Ranger is like an old show, by the way. So what we're going to do is we're going to do row total times column total over table total. So in this scenario, if we're trying to do Lone Ranger and boys, here's Lone Ranger, here's boys. So this one is nice because it already did the totals for you. So we've got, for Lone Ranger, the total is 100. And I'm sorry, that was the column. The row total is 100, and it doesn't really matter since the numbers are the same. And the table total was we surveyed 300 people. And when you do that, you get 33.33. So that's how you would do it if you wanted to do it by hand. You could also do it by calculator, which comes a little bit later in the video. Okay, so what we're going to do now is we're going to answer this question from start to finish. Is there an association between gender and viewing preference? All right, so we're going to start by writing our hypotheses, and the null hypothesis should have the word no association, and the alternative should have the word association. So there is no association between gender and viewing preference. And the alternative hypothesis would be that there is an association. And we can choose an alpha, and like always, I like 5%. All right, so that's how you write the null and the alternative hypothesis. Now, in the first slide, I showed you how to do the expected values for one cell. And this problem was actually a pretty big problem. There's 1, 2, 3. So this is going to be a 2 by 3. So this means we'd have to do 6 of these total. And I don't want to do 6 of those. So I'm going to use my calculator to figure out the rest. Okay, so the planning portion of this problem, we have to figure out if the problem is random, independent, and large enough. And this always refers to the expected values. So we need our expected values before we can do anything else. So what we're going to do now is I'm just going to give you guys some calculator commands on how to do this. Okay, so we want to enter our observed value. We're going to go to second, and then we're going to go right here where it says matrix. And then we're going to edit, and then just push the enter key. And you want to enter the dimensions. And so this problem, I'll just bring it back for a second, has 2 rows and 3 columns. Don't include the totals. The totals are not part of the matrix. So really we're talking about here to here. So that's a 2 by 3. So we're going to switch that to a 2 by 3. And you'll see it adjusts to the size you need. So you're going to enter in the numbers again. Hopefully you pushed pause earlier and you wrote down those numbers. Okay, and then we have to turn on the chi-square test. And I know it seems a little backwards, but this is how the calculator does it, so you have to do it in a calculator order. So even though you're like, I really need the expected values, the calculator can't give you the expected values until you do the test. So to do that, you're going to go to Stat, Test, and you're going to choose C. And that should say chi-squared. I don't know what happened there. Okay. There's 2 to choose from. We're not doing goodness of fit. We're doing chi-squared. So just like this says, this should say A and B. And when you're ready, you're going to go to Calculate. And those are the answers. And we're going to need those for the later on. So I always like to write them down in the margin. So that I have that for later on in the problem. Okay, so the third thing we need to do to get our expected values is to go to, we did this, run this, do the chi-square test first. We did that. So we're going to go back to that matrix menu. We're going to go to Edit. But this time, instead of going to A, we want B, because that's where the expected values are hiding. And those are all the numbers you need. So we're going to use that to write down in our conditions part. So we don't need this anymore. Okay, so the problem did say that the children were chosen at random. Before we do that, let's go ahead and write down our values. So it was 33.33, 66.67, 36.67, 73.33, 30, and 60. Okay, so we're going to use our we're going to use our expected to answer these questions. Now, it did say in the problem that the children were chosen at random. And let's see, there were 300 kids total. So I'm pretty sure that there's at least 3,000 kids out there. So we have a population at least 10 times the sample. Okay, and then our next conditions always have to do with the expected value. Okay, we want to make sure that we don't have any zeros in the denominator. So one of the conditions is that all expected have to be at least 1. And looking at them, we're good to go. So all expected at least 1. The other condition is that you're allowed to have some small numbers in here, but you can't have a lot of small numbers. So the next condition is no more than 50% of the expected can be less than 5. And we're good here because none of them are less than 5. So since all the conditions work out, we're going to use a chi-squared test. Okay, so now this is easy because we already did the problem on our calculator. So we have to show substitution to show me that you understand where these numbers are coming from. And I always just pick the first cell. You could pick anyone, but I chose boys in Lone Ranger. And so that's how many boys I saw in the study. Watch the Lone Ranger. This is how many I expected, divided by how many expected. And you don't need to do every single cell. You can just write plus ... and the answer. And we already did the answer using our calculator. And the answer is 19.32. Now, degrees of freedom here are different than goodness of fit. They're row minus 1 times column minus 1. And I know the calculator did it for us, but it's good practice. So there were 2 rows and 3 columns. So that means the degrees of freedom were 2 in this problem. The calculator also told us that the p-value was 6.38 times 10 to the negative fifth, which is 0.0001234.638. That's a really small number. I'm just going to go ahead and call that 0. 0 is less than 5%. P-value is less than alpha, and we know that that means reject H naught. So in conclusion, we do have significant evidence. I'm just going to abbreviate for time. And don't forget to write your significance level. That there is an association between gender and viewing preference. All right, and I think that's it. We've gone through the calculator, we've gone through how to do it by hand, and just one more time in case you want to pause this and write this down, here are the commands to the calculator on how to enter it into the calculator. All right, everybody, good luck and see you in class.